Hi, I'm Miss Hall, and this is lesson 53, Simplifying and Multiplying Rational Expressions.
Hi, I'm Mr. Sajak. A rational expression is a fraction. You see the word ratio there, which means fraction. So a rational expression is a fraction whose numerator and denominator are non-zero polynomials. That means we're looking for terms with x or x to a power in both the numerator and denominator. The domain of a rational expression excludes values that make the denominator 0. That will be important in just a moment. A rational expression is in simplified form when its numerator and denominator have no common factors other than plus or minus 1.
Okay, let's look at this example.
And we'll go through some steps.
Yeah. Step number 1. You're going to factor the numerator and denominator.
We can see that step has already been completed in the example that we started.
Step number 2, divide out common factors.
We see that occurring with the red slashes through the numerator factor of x plus 3 and the denominator factor of x plus 3. When we divide those two, we of course get 1. And we are left with 4 over x plus 3, a simplified form of the rational expression.
There is one more bonus step that we're going to see in example 1.
Okay, so we're going down to example 1. Our first step is to factor the numerator and denominator. We'll factor the quadratic trinomial into x minus 6 and x plus 2. We'll check that that is correct. Negative 6 times 2 is the third term of negative 12, and negative 6 plus 2 is negative 4, the middle term. We'll factor the denominator into x minus 2 and x plus 2, as it is the difference of 2 squares.
And we've just done step number 1.
Step 2, we'll cancel out the common factors of x plus 2. When we divide those, we of course get 1. It may be helpful to you to write 1, and that is equal to our simplified rational expression, x minus 6 and x minus 2. But this is not a complete answer. We have simplified the rational expression, but we lost some information from the original problem. Step 3
is to restrict the domain.
If you go back to the second sentence, the domain of a rational expression excludes values that make the denominator 0. That's from the original rational expression. In our original rational expression, we had 2 values that made the denominator 0. It might be easiest to see them in the factored form. We see that x equals 2 would make the denominator 0, and we see that x equals negative 2 would make the denominator 0. In our simplified version, we still see that x equals 2 would make the denominator 0, but we lost the information of x equals negative 2. We must now state that x cannot equal negative 2 in our simplified version because x could not equal 2 originally in the original rational expression. So we have now restricted our domain to include that original point where the rational expression was undefined. Okay, so for example 2, Ms. Hall and I are both going to show 2 different ways to do this. And we're going to end up with the same result. Math works no matter what, but you should pick the way that's most efficient. So we're multiplying rational expressions. These are rational expressions because they're polynomials in terms of x and in terms of y. All right, so what I like to do is I like to reduce as much as possible first. Making things smaller for me is easier. So I see a factor of 8 in the numerator and a factor of 2 and 4 in the denominator. We all know that 2 times 4 is 8, and 8 divided by 8 is 1, so I'll leave that there. So we're left with x cubed y over xy squared, we will reduce that in a second, times 7x to the 4th y cubed over y. So now I'm looking at my y's. I see y squared and y, that's y to the 3rd, so that will cancel out with this y. And I see, did I write everything correctly? Mm-hmm. Yep, x to the 3rd and x to the 4th. That would be 7x to the 7th, so I just combined x to the 3rd and x to the 4th by adding the exponents. We had a 7 and we have a y. Okay, so I'll put y over, and then I have one factor of x remaining. When we divide factors with the same base, we subtract exponents, so we get 7x to the 6th y. The one thing we need to make sure to remember here is that we restrict our domain. So we have to go back to the original problem. Let's do some erasing. And in the original problem, we saw that there are factors of x and y. So x cannot equal 0, and y cannot equal 0 in the original expressions. We no longer have a denominator in our final simplified version. So we need to write x cannot equal 0 and y cannot equal 0. And that
off the page.
is our final answer and is off the page. So.
Okay.
Do you want to clear the screen?
No, I'm just going to say, so Mr. Sajak does steps as he does steps. And what I like to do is just write everything out. Rewrite the numerator of the original, combining those numerators and putting like terms together. So I have 8 times 7, then I put my x terms together, x cubed times x to the 4th. Then, yeah, you're right, times y to the 3rd. So I'm just rearranging it. And then I'll have 2 times 4 times x times y squared times y. And then I do all my dividing out common factors. So I see a y and a y, so just 1. I can get rid of 1x, so this becomes x squared, 1. And 8 is the same as 2 times 4.
What about this y cubed and y squared?
So I have y squared and I have y cubed, and that gives me just a y. And now I rewrite what's left, which is 7. So now I've taken care of that. The x's are x to the 6th.
Oh, wait.
And I have a y. And in the denominator, everything's gone. I could put over 1, but I'm not. I'm just going to put no denominator, and then I just have to look for what did I cancel out in the bottom. It's going to restrict my domain, and that is that x cannot equal 0 and y cannot equal 0. Okay, we got the same answer, whichever makes the most sense to you. Example 3 is going to be the same 3 steps that we've been doing.
But this one's more fun.
Number 1, factor the numerator and denominator. So we're multiplying, let's see.
We see a GCF of 3, a greatest common factor of 3x in that numerator, left with 1 minus x. Denominator?
Oh.
Okay, numerator?
I just go right across.
Okay, x minus 4 and x plus 5. We'll check to make sure that that's correct. Negative 4 times 5 is negative 20. Negative 4 plus 5 is positive 1. And that's good, that's correct. The denominator on the left, x minus 1 and x plus 5. And then 3x, we can't really factor anything out of 3x, it's just one term.
Okay, second step, divide out common factors. I see this 3x.
I see x plus 5. Does anyone see anything else?
Look closely.
Okay. You see 1 minus x and x minus 1. Those are almost the same factor, but they're different because each term is opposite. Is there anything we could factor out of the numerator so that it would be the exact same factor? And of course the answer is negative 1. So we're rewriting 1 minus x as negative 1 times x minus 1.
This is going to be a trick you should look for.
Right, so if you ever see, now be careful, if it were 1 plus x as the factor, that is not the same. So we've now replaced 1 minus x instead with negative 1 times x minus 1 so that we can cancel out the common factors of x minus 1. That does leave us with a negative 1, so we will make sure to write that. So we have negative 1, we have left negative 1 times x minus 4.
And because I'm going to write this again, I'm going to put here the denominator is 1.
Because there's nothing left in that denominator.
And now I'll rewrite this. I'll distribute that negative 1 and get negative x plus 4.
We've completed step 2, which was to divide out common factors. Now we need step 3 to restrict the domain. This is any time the denominator is 0. So we had 3 factors in the denominator.
So I like to write these as what are the x values that make these 0 and then restrict the domain. So the first one, when x is 1. Second one, x is -5. Third is when x is 0.
And you notice we don't have any domain restrictions in our simplified version of the rational expression, -x plus 4, because we don't have a denominator anymore. So we need to restrict our new simplified rational with each of these domain restrictions, 0, 1, and -5. And that's our final solution.
Okay, for this try question, we're simplifying a rational expression. Let's do the same 3 steps. First, factor. Numerator cannot be factored.
Yeah, the greatest common factor is 1, so we can't factor.
Denominator. Ooh, looks like it can't be. Oh, wait. It's a difference of squares.
I mean, it's literally x squared and y squared. They're both squares.
So a plus and a minus. That's the first step, factor. Second step, divide out common factors.
We don't have any common factors.
But I have one that looks exactly opposite of each other.
Oh, yeah, that one. So we could factor out -1 out of the numerator or the denominator, but I always like to do the numerator. It just makes it easier for me.
And now we have common factors that we can divide out. We are left with -1 over x plus y, which is choice 4.
Here's a bonus point if you can figure out what would the domain restriction be, because we didn't complete step 3 and neither did the regions. Can you figure it out, Miss Hall?
When x equals y. Yeah, so if you wanted to add that, x cannot equal y. Because I set this equal to 0. When is that 0? And that is when they equal each other.